Hey everybody, it's Kyle again from Meister Vision, this time with another Raspberry Pi tutorial. Previously I had posted a demo showing a Raspberry Pi internet radio little device I'd made, and this time I wanted to actually give you guys a step-by-step tutorial to show you what I did and let you make your own, and to see what you come up with. So first off in this tutorial I'm going to go through the parts that you're going to need. I'm going to show you how to wire up the LCD display. Also, I have an LCD test program that I want you to download, and then that'll make sure everything is wired up correctly for the LCD. Additionally, we're going to go through the wiring and installation of the push buttons. We're going to be using two push buttons that should go to the next channel and the previous channel, and to cycle through all our different radio stations. Also, I'm going to show you how to use MPD to create playlists of your radio stations, and then I'm going to also give you some troubleshooting on how to make sure that your audio drivers are set up correctly, and how to get everything working on that end. So additionally, then I'm going to have you download. I have already put together a script that's a basic radio program in Python. Have you download and install that, and then finally we'll get you listening to your own internet radio off of your own device, and you can just totally nerd out. It's the ultimate nerd device, I think. So anyways, I hope you guys enjoy this tutorial, and please let me know if you have any comments or suggestions or questions. And again, if you like this and you enjoy the tutorial, please subscribe, please like it. Thanks. Alright, so first is parts, what you're going to need. Of course, you're going to need a Raspberry Pi. I got this one, it's set up here. And you're gonna, if you guys don't know what a Raspberry Pi is, then maybe you should go Google that or YouTube it. But basically the Raspberry Pi, is, as many of us know, is a $35 Linux computer that allows access to what we call general purpose input-output pins that lead right to the processor, and so we can do a lot of embedded electronics with that. And it's really good for people like us that are hobby makers and people interested in electronics and computers. But anyways, this is the Pi. I have it on a dude, I forget this called, like the freaking. This is from Adafruit. This holder, and I have a breadboard. So you're gonna need a breadboard of some sort. You're gonna need the ribbon cable. I guess you don't 100% need this, but it makes it easy. And this is actually the right here is the breakout. A GPIO breakout from Adafruit, and it's actually labeled specifically what these pins mean, and this is way helpful. And so you just will actually just plug. You guys will actually just like plug the ribbon over here, stick it in there, and this will break out the GPIO to our breadboard. Real easy way to do this. So that's that. Right now I have the Raspberry Pi hooked up to Ethernet. Although you could use Wi-Fi if you wanted to, which I have used in the past. And I'm actually just we're going to do 3.5 millimeter audio out and to some external speakers right now. And I think we'll do it over here to this old iPod dock. And I used that in my previous demo, so I thought it might be cool to show that. Also, you're going to need an SD card with Raspbian Wheezy, the Raspberry Pi Foundation Linux distribution. I'm actually using Adafruit's Occidentalis distro. This is the second iteration of it, and it's based off of Raspbian Wheezy. It just adds kind of some extra driver support and some other little bells and whistles, and I think I like it, so I've enjoyed working with it. But I think that everything here should generally work with Raspbian Wheezy. You may have issues initiating the sound drivers. But I'll show you how to do that if it comes to that, and what codes you need to do. What do you need to type in to get that to go, and what config files you need to change to get those audio drivers going, which they are in beta, I think, so that's why they haven't really took off. Okay. Also, you're going to want some sort of LCD character display. This is actually this is a 20 by 4, so we have 20 characters across and 4 lines. This is a little bit overkill. You guys can use just a regular 16 by 2. And we're not doing anything special with it. We just have the pins here, and we're going to hook it up. I think this is actually an RGB, but that's not going to be a big deal. So, and this goes to a different one, but this is going to tell us some sort of documentation showing us where the pins go to. And I'll show you guys how to wire it up and what we need to install to get this working. on the Raspberry Pi in Python. Okay, you're going to need some, this kind of goes without saying, but some jumper cables for the breadboard. We're going to be needing quite a few of those. And then also, these are, I mix up the size. I think these are 6.5 millimeter tactile push button switches. These are from Microtivity off of Amazon, I think, and they're fairly inexpensive. But I just got a pack of them, and we're going to use these little push buttons to actually tell the Raspberry Pi to change station, to go forward or backwards on our stations, and maybe we'll get into volume control. Last but not least, I'm going to kind of go off the assumption that many of you have already familiar with the GPIO and what the different header numbers, what the different pin numbers correspond to, what they do. I'll tell you what to plug into where. And but I think a good starting place before you guys get into this tutorial will be Gert Van Loo's. He has a great YouTube tutorial on the GPIO on the Raspberry Pi and how to get that going. So I'm not going to go into too much depth on the GPIO and how everything is numbered and that sort of stuff. But I mean, we'll get you going. But it may help if you guys do that. I'll put a link in this tutorial to for that tutorial that I just spoke of. And I'm trying to think what else you guys may need. That's pretty much it. As you notice, I'm just going to be using PuTTY to SSH in to the Raspberry Pi. If you guys need help setting that up, I have put tutorials on that kind of go into depth about that, but that's how I'm going to be interfacing with the Raspberry Pi. I'm not going to even I'm not going to plug it into a monitor or anything. And but yeah, that's what you need to do this project. It's not a ton of stuff, but I think it'll be pretty fun. Okay, I just realized I forgot that we're going to need one other component for this, and this is just a little potentiometer to control the contrast on our LCD display. And these most often are included when you buy these things, especially if you get them from Adafruit or Microtivity off Amazon. You're gonna get one of these guys, but we're going to use this. This is important because that's how we're going to change the contrast on the contrast on the LCD display. So now we should have everything. But let's talk about let's go into actually wiring up our LCD display and going through each of the pins and getting everything set up just how we need to get it set up. Alright, so the first thing we're going to do is we want to bring over to our buses, our positive and negative buses, our ground and our power buses. We want to bring 5 volts over from the cobbler, which will be the GPIO, and we're also going to want to bring the ground over. And as you look on our, this is a great thing. I printed this up. This is from Gert Van Loo. I'm not taking credit for this, but this is a great little handy thing to have. As you can see, so we're basically going to break out pin 2 here, which is 5 volts, and pin 6, which is 0 volts. And this is it actually fits like this. So that's how we can kind of keep track of it. And we actually have it listed along the sides what the pins refer to. So this is a really easy way to do this. But we want to basically break these out onto our buses so we can just easily connect up our positive and negative connections there to the LCD. So let's go ahead and do that. So first, let's see. Sorry, I'm breaking out my breadboard wires here. But we're going to get a couple, let's see, I don't want really long ones. Okay, let's get at least one red one, one black one. This helps remember. So I know it may be difficult to see. Let me try to tilt this up. Okay, hopefully you guys can see this really well. But the first pin here is actually our 5 volts. And make sure I put it in the right one. Alright, right there. And then I'm just going to actually just jump it over here to the to our power bus here. And then ground is right here. You can see ground, so that's the ground pin off of our GPIO. And oops. And just as kind of a side note, safety precaution, or just a precaution if you don't want to screw up your Raspberry Pi. As you notice, I don't have the cable plugged in with the Raspberry Pi on. My Raspberry Pi is actually on right now, But this is all, there's no power going to this right now, so that's really important, so you don't short out anything or fry your Raspberry Pi. So right now we got we have it broken out where we have now access all along these buses for both the 5-volt and the ground connections. Okay, so first things first, let's start hooking up the our actual LCD display, excuse me. And this is going to be slightly different than, like I said, than a 16:2 display. But actually, most of the pins are all the same, except for, I think, the last few. And I'll show you that. But first off, the first pin number 1 is actually going to be a ground. It's going to connect directly to the ground. So let's go ahead and place a jumper wire in there and run it right over to our ground that we just broke out. So pin number 2 is actually going to be 5 volts. So you just go pin 2 here, and we just run it over to 5 volts right there. And pin 3 is a little trickier. For this, we're actually going to need our potentiometer. Pin 3 will actually break out to the potentiometer. Excuse me, it's a hard word to say, I think. And so we're going to need also, I'll show you how this works. Pretty simple. Alright, so what you're going to want to do is just find a good spot for it. I think probably right over here is going to be a decent spot. And let me get this in here. Okay, so it's in. Did I put it? Okay, yeah, that's about right. Okay, so we have 3 different pins over here. Hopefully I put it in the right direction. Did I put it in the right direction? I think so. Find out if it isn't. But we have 3 different pins, 3 different wires are going to come out of here. On our leftmost wire, we're actually going to run 5 volts, and just run that over to the 5 volt over there for bus. The 3rd pin is actually going to be ground, no surprise there. And then this is a tight squeeze, but the middle pin here is actually going to run over to pin number 3. So it should be this next one right here, pin number 3 over here on the LCD display. So as you can see, we're building this thing up pretty nicely. We got our potentiometer in. Let's just keep on plugging away. Let's see. For what I'm going to do right now is I'm actually just going to finish hooking up the pins that need to go either to ground or to power, and then we'll go in and fix all of the actual data pins that's going to send data to and from the LCD display here. But let me see. Let me make sure I get this right. So starting back from the end, if you do pin, let's see, what is this? This is pins. We got 18, 17, 16, pin 15 is going to be 5 volts. So just run that over to our bus again. And then the only other one that's going to be plugged like this, for now at least, will be pin, hold on, I'm like totally looking at the picture while I'm doing this. It's going to be pin number 5. So we've already done, and as you can see right now, I think I've actually messed this up and they're off by 1. So let's move these over. I don't know if I did notice that at first, but yeah, it's totally going to be off there by 1. So let's go ahead and move these over. 1, our first 3 moving over 1. You guys probably caught that, and I'm just an idiot sometimes. But hey. Okay, so we want to do then pin 5. So we skip a pin for 5 is here. 5 is just going to go right over to our ground again. So this is all basically the all of our power connections that are going to be needed to power the LCD display. One other thing to note when you're using an RGB display, since you have these 18 pins, these last three pins right here, which is 16, 17, 18, actually correspond to the red, green, and blue LEDs that can backlight the display. And so you can actually plug in all of these into the GPIO and be able to control kind of mixtures of colors. And that's really cool if you want to kind of do a whole bunch of different colors, like tons of different colors, and be able to change it through the software. But actually, I just want to do, I just want to have the red, or excuse me, the I like blue, and so I'm actually just gonna power up the blue. I want to put power to blue, so red, green, blue. So pin 18, I'm just going to run over to power as well. And if you want it to be red, you could just run this pin here, 16, which corresponds to red, just run it over to power. If you wanted to combine colors, so if you wanted to kind of have a, and I'll show you that later, but if you wanted to have like a turquoise color, so you would want to mix green and blue together, you would just give power to both the green and the blue pins, and it would give you a perfect match or a mix of those two. And that's kind of a shortcut way of choosing if you want to have if you want to have a set color on your LCD display. That's kind of my trick that I use mostly, just to free up input and output pins that we may want to use later. Okay, so now we're going to hook up our data. We're going to hook up the data pins that we need to be able to send data to the LCD display. From the Raspberry Pi, and we're going to hook up these over here to the GPIO breakout corresponding to our GPIO pins that we're going to want to hook up to. And this particular breakout board by Adafruit, actually written on the silk screen are the numbers, the GPIO numbers and everything, and what they are. And this is kind of a this took me a little bit to figure out, but these are actually Broadcom names, and the Broadcom board names as opposed to the physical Raspberry Pi names. So when referring to it, when I say GPIO 23, I'm actually talking about pin 16 or pin 18 or whatever. So you can see there's a bit of a difference over here because we have GPIO 4 corresponds to GPIO 23, and this is just differences in the Raspberry Pi, how they name it versus actually what the physical chip is, what it's named as. So, and we'll show you how to specify whether you want to, if you want to use Broadcom names or you want to use the Raspberry Pi names in your code. All right. So first we're gonna move on. We're gonna move along, and we're gonna go to pin 4, which we skipped here, and let's see. Kind of digging through my cables over here. Alright, I wish I had more colors, but I don't have a lot of colors, so you'll have to pardon me. Let me just grab a couple over here. Alright, sorry, it's taking a little time. Okay, so I got a few of them over here. But let's go ahead and use the green. I'm going to use the green, and we're going to plug that into pin 4, which we did skip before. And pin 4 is actually going to go to the shoot, let me see. I think it's number 25. Let me see. Yeah, so this is actually the Broadcom number 25, and let me get you a better. I know this may be shaky, so I'm sorry, but I want you guys to be able to see this, what I'm doing. So I'm just actually going, finding 25, which is marked right here, and we're just going to plug it in right there. So now that'll correspond to that pin 25. Well, it's actually the GPIO 25, which is actually pin 22. A little confusing. But go watch that tutorial if it's still a bit confusing, because I think Gert does a really good job clarifying it. And Gert was one of the main dudes behind engineering this thing, so by this thing I mean the Raspberry Pi, so he's legit. Okay, this might be a better way to look at this. Maybe we'll keep it there. Okay. Next we're gonna go, let's see, we already did yellow. Or we did the green, sorry. We've already hooked our ground on pin 5. So pin 6 is going to be, we're going to do it to the GPIO 24. So let's go ahead and do 6, and we're going to run over to 24, and let's see, where's 24? Okay, it's actually it's over here, just marked like the other one is. So I'm not going to give a zoom every time, and I'm not going to zoom into it every time. Okay. Next we just skip pins 7, 8, and 9. So that's really cool. Thank goodness we can do that. So by skipping pins, we go 7, 8, 9. So we got, I have to count this over and over again. We got 1, 2, 3, 4, 5, 6. So 7, 8, 9. We skip those 3, and now we're on pin 10 here. And we skip 10 as well, sorry. And we're going to be on pin 11. So starting at pin 11, we're actually going to connect, I'm going to use a blue wire for this, so 7, 8, 9, 10, 11 is here. And this wire, so the 11 pin on the LCD, is going to run over to the cobbler number 23, so the GPIO 23, which is going to be over here. I'm sorry this isn't very easy to see, but I'll kind of show you a close-up after we get all hooked up. But it does start getting kind of overwhelming pretty fast, with a lot of wires, so I thought it'd help if I walked through it. Alright, so now we're going to do pin 12. And pin 12 actually hooks up to, sorry for the bump, pin 12 is going to go right here. And actually I'm going to get a longer, we're kind of running out of some space, let's get some, alright, I'll use this green wire, but pin, so we're on 12, right? You guys, so let's see, 1, 2, 11, 12, yeah, 12. So pin number 12 over here on the LCD is going to go to GPIO 17, which is actually corresponds to pin 11, and it's right over here. Yeah, you guys can see that, right? Yeah. Okay, cool. Alright, so we got 2 more to go. We're almost there. Again, I'm going to try to get a longer one. But we have pin 13. Goes here. Is actually going to go to... we're going to go over to the GPIO number 21, which is right over here by 17. And good there. Now finally, pin number 14. Almost done. I'm going to use this yellow wire here. And pin 14 is going to go into GPIO number 22, which is pin 15, which should be right here. Yeah. Let's see, it's right. These are all right next to each other. Okay, cool. So we actually have successfully hooked up our wires to our LCD display. And now let's get some software over and some libraries over into Python and be able to see if we can send some basic text over to this to test it. Okay, so I just hooked up. I just want to test and see if our actual display works. At least it'll power up. So this is no software involved. So I just went ahead and hooked over the GPIO ribbon cable over from the Raspberry Pi to the GPIO breakout over here. And one thing I did, so what was happening was it was just black. So if it's black, it means something's wrong. Because right now we should be getting power to it. But what I did mention that was incorrect is over here so on the actual blue, so we want it to light up blue. This does not go to power. This actually is grounded. And you should see that happen right there. Alright, so now that we got everything hooked up, we know it's working. I wanted to show you just how to change the colors real simply through our wiring instead of doing it through software. So right now we just see that we have the blue pin here grounded, so that is what we're seeing is just blue. But if we wanted to activate the green pin, we would just go to the green pin 17. We'd ground it as well. And since they're both activated, we get a turquoise color, which is cool. So not as deep as a blue. If we wanted to just have green, we could just take off the blue. Likewise, if we wanted the red, we would just plug in red. Now, if you want to do pink, we would just mix red and blue to give us kind of a purplish pink. Yeah, it's kind of a fuchsia color, I guess. It's not showing up the same color on here, but yeah. So that's how you do it through software. But just for the sake of what I think is cool, I kind of like this more greenish turquoise color, mixed between green and blue. So we're just gonna leave it at that. But that's just a basic intro on how you can change the colors without having to use up GPIO inputs and outputs. Okay, so now we want to install a Python script that's just going to test if we can print output to the LCD display from the Raspberry Pi. And so for this tutorial, I'm actually combining a tutorial by Raspberry Pi Spy, and I have the address, and I'll post it on the description. This gives a really good description with wiring, with a wiring diagram as well, and what each of the pins on the LCD screen do, and what what GPIOs they should correspond to as well. They also provide a code here, and the code, I'm going to post my own separate script, but it's based off of this. The only difference is how I wired the Raspberry Pi up does not correspond to what they actually give here. So in the script, I'll put a Dropbox link to it, but you'll at least want to change your GPIOs, how they're mapped, because I wired it a bit differently. And also, we're using in this tutorial, I'm using a RGB display. This is not set up for an RGB display, so that's just something to keep in mind. Okay, so now that we have our Python script, now we want to move it over, transfer the file over to the Raspberry Pi in our home directory. So to do that, we're going to use a program called WinSCP. So it's WINSCP. And this is a program that Gert has used in his tutorial on the GPIO header. So if you want to know where to get this and that sort of thing, go to his tutorial. But this is just using SSH, so just like we did with PuTTY. It's very similar. So I'm going to go ahead and create a new one, and I'm going to, since I'm using Bonjour, I can just point to the Raspberry Pi using raspberrypi.local and log in that way. One thing you could do is you could actually just type in your local address here if you knew your IP address. Alright, so we'll update the key. It's asking for our username, so I'll use Pi, and I'll put in my password for Pi, which default is Raspberry. Okay, now we get we can see we have our local files over here, and then we have the files that are on the Raspberry Pi over here. And this is our home/pi directory. And what I want to do is I actually want to create a new folder in here, in our projects folder. You may not have one, but you can create one as well. This is how you do it, and we're just going to type in a folder name, and I'm going to call this radio. Okay, then we're going to go into the radio folder. Now we want to find that file that we just downloaded, and I actually put mine in, I have a Raspberry Pi folder, and then I put it right here, the 20x4 LCD test.py. We're just going to drag it over there, and it should be successfully there. So to check that, we can use PuTTY, since that's what we were using over here. Let's log in as Pi with our password again. Let's see where we're at. So we want to go to CD projects, CD radio, and you should see right there we have a 20x4 LCD test.python. And this is the Python script that you should have downloaded from me, because if you wired it up how I showed you and you used the one that's off this website, Raspberry Pi Spy, it's not gonna work. You could rewire it to fit their specifications. So now we're just gonna run the Python script here, and we'll just as root. Alright, so now let's go over to the Raspberry Pi and take a look at if it's showing us anything. Alright, so now that we moved over the Python script, let's go ahead and fire it up to test the LCD. display. So just do, like we said, sudo python, and then the name of the file, which is 20x4 LCD test. So once we hit enter, this is what we should get. So yeah, it says Raspberry Pi Model B, and it switches to Meister Vision, it gives us that, and then it should hold that for like 30 seconds, I think, and it should clear the display, and it'll be done. So that's so that we know it works. So that's great. So now that you know that now that we know everything is wired correctly, we have the software that can run it. We have the software driver to be able to control the LCD display. So that's kind of the biggest and probably hardest step to this whole process. This whole project is just getting the display to work. If you're not getting things to show up, the first thing I would suggest is looking at your potentiometer and adjusting that. Let me go and run it again so you can see what it looks like when it's not properly adjusted. So if I'm over here adjusting it, I don't know if you can see over here, you can see that this totally affects the contrast. Yeah, so the first thing I would definitely check is by adjusting the potentiometer. A couple other things that may, beyond that, I would say just double check your wiring, make sure that they match up. The pins on the LCD actually match up with the GPIO header numbers that we're using in the software. So if you wired it up like I did, like I mentioned to do, then you're going to want to download the file that I created, that I edited from the Raspberry Pi Spy site, so that it's wired correctly. Other than that, I would say just go back and look at it. It'll be a little bit different if you're not using an RGB display. We already kind of talked about that. Alright, so the next thing we want to do is we want to actually hook in our two tactile switches. We should have two of them, and so that we can change the channel from next to previous. So we're gonna, once we hit that, then I'll go to the next channel on our playlist. So in order to do this, this is something I didn't include in the parts list, but you are going to need two resistors. Any kind of small resistor should work that you'd use for LEDs. And you're going to need a couple extra jumper wires. So let's, first off real quick, just so we're on the same page, just to understand the way these push buttons work. Let me get that in focus there. If you look at the bottom of these things, it's kind of confusing because it looks like there may be 4 different wires that need to connect to it, but in reality it's only two different sides. And if you look at it from this way, these 2 wires are actually the same exact, they're connected together, and then the bottom 2 are connected together as well. So we're going to actually put it in like this into our breadboard, and then we're going to connect one of our wires to the GPIO over here, and then one is going to go to power with our resistor to power. And that way, once you press the button, then these 2 will connect. These 2 sides actually will connect. That's a little bit confusing, but let me just let's go ahead and install them. So find a convenient place to put them. I think I'm just going to put them over here, just because we have some space and it's relatively open. So you just get them into the breadboard. Okay, so now we want to take our jumper cables and we actually want to hook. So this is going to be the next button, by the way. This is going to be previous channel. So let's go ahead and hook up the previous channel to the GPIO. So we're going to do this left side over here. Remember, these are both the same wires, and these are different wires, and when you press it, they connect. So we're going to put in the breadboard for the previous button. And previous is actually going to go into the number 4 pin. So if we just look for number 4 over here on our breakout. And I am using Broadcom names for that. So that is the GPIO number 4, which is actually pin number 7. It's specified to pin 7 over here on the GPIO header. And then for the next button, we're going to just go ahead and plug that in on one side. And this one's actually going to be in the GPIO number 18. So let's go ahead and hook that in. Alright, now finally we want to actually connect the other side to power. And we're going to use these resistors to do that. So you just take it over here. I'll start off with, let's do previous to keep the same order. And then we're going to plug it right into power, our power bus over here on the breadboard. Just make sure it's in there pretty sturdy. And we're going to do the same thing for the next button. Alright, so now that they're all wired up, we're ready to go ahead and install the software to get this running. But before you do that, let's just go ahead and hook back up our GPIO ribbon cable. Okay, so the first thing we want to do before we actually get going with the media player, we want to make sure we have MPD, which is the Media Player Daemon, installed on your Raspberry Pi. That's the basis for the internet radio that we're going to be using, the software-wise. And we're actually using MPC, which is the client, to actually send commands to play the internet radio stations and to change the channel. So to do that, we're going to want to first install MPD and MPC. So you do sudo apt get install, and it's just MPD space MPC. And I already have it installed. It should be it should be up to date, but let's see. Yep, it's telling me it's already the newest version. But you may have to hit Y to continue to install it. So another thing you're going to want to make sure you have installed, you may already have this installed depending on your operating system, is the ALSA utilities. So it's just the command to do that is sudo apt get install ALSA ALSA -utils, and you just hit enter on that. Okay, so I already have it and it's up to date. Okay, cool. And then one other thing, well, first off, let's just go ahead and test to see if we're getting sound. So to do that, we want to first add an item to our playlist. And over here on the left side, or the left part of the screen, I have Soma FM. They have direct links to their radio stations. And this particular one, we're just going to use the direct server. We're just going to do MPC space add, and then we're going to type in the direct server name, which is http ://fss. Oh, that's a backup. Hold on. mp1.somafm.com, and the port is 8800. Okay, and then we don't get an error, so it added. So now we should be able to say MPC play. Yeah, so it's totally playing. I don't know if you guys can hear it on the speakers. And so we can do MPC stop to stop it. So we know that we have the audio working and MPCs working with MPD in the back. That's really important since this is how we're going to be basing everything, all of our codes using MPC. Okay, so if you're not getting audio output, there's a couple things that could be wrong. The first of which I think is pretty common, is ALSA, or ALSA, I don't know how you say it, may actually not be initializing on startup by default, because I think for the Raspberry Pi right now it's in beta. So in order to do that, you're going to want to edit your etc/modules file, and we want to make sure that we have our sound driver, our sound chip in that file. So to do that, you're just going to do sudo nano, and that's /etc/modules. And it should bring up right here. And you want to make sure that in this file that you have snd-bcm 2835 somewhere in there, and make sure it's not commented out or anything with the number sign. So as you can see, it's here for me. So that way on boot, it'll automatically initialize the sound driver. That's the first thing you want to do. After you add that, if it's not working, then you're going to want to restart the Raspberry Pi. So we want to do sudo init6 just to restart everything up. Okay, the second thing that may be going on if you're not getting sound would be that the Raspberry Pi is not selecting the proper output. So you have HDMI, and you also have your analog or headphone jack that you can output sound on. And by default, the Raspberry Pi is set up that it'll auto detect what's plugged in to determine which way it's going to output sound. So actually on mine, I have I'm actually using HDMI out. Actually, I'm not plugged into anything, but I have been using HDMI out. But let's say you want output to your stereo, that can be an issue. But the way you can manually set up which mode that you want to use for your audio output. And to do that, you should have installed the ALSA-utils file, or program, excuse me. And once you've done that, the command you use is sudo amixer, amixer,
XER. You do a space and you do CSET, and then num ID, and it equals 3. And if you just do that, that'll set it to automatic on default if you hit enter. But now we can give it either a 1 or a 2 over here. So a 1, if you say 1 after the space at the end, we'll set it to headphones or the analog out. If you set to 2, that will set it to HDMI out. And you just hit enter after that. So that's one thing that that may be catching you up, and that's a quick solution to it. And if those two things fail, then I would just say Google it or ask some people around, because that's I guess the extent of my knowledge on that. Okay, so the next thing we want to do before actually installing and running the Python script for the radio player is we want to build our MPC playlist that's going to have all of the links, all of the addresses to the internet radio stations that we want to have in our list that we can cycle through. So what you need to have this is really a direct server address. This can't be an M3U file. It can't be a PLS file. Although I'm going to show you real quick how once you have one of those, what you can do with it. But the easiest way to do this is going to be to so Soma FM. If you just Google Soma direct links, stream links, they'll actually give you a direct server down here. That's what you're going to want. So it actually has the server address and then a port number. So I'm going to show you real quickly how to add one of these once you already have that direct address. So I actually want to look for Soma FM. So we just Google direct links. You can see I've already been over here before. But let's just do, for the sake of it, how about secret agent? And so you can just pick up right here. You have your different bit rates. But I'm just going to do MP3 128, and you can see the direct servers right here. And so to add it to our MPC playlist, we're just going to do MPC and then space add is the command we use, and then we just type in the server. So it's actually http mp2.somafm.com. And so you've already seen me do this probably before. 90.16. Okay, so it added it. If it didn't give us an error, we're good to go. However, if you do mistype it, I don't think it'll give you an error here. It'll take anything. So make sure you type it right, and you'll notice if it doesn't work when you try to go to that station. But next I want to show you a good resource for actually getting new stations, and it's actually radio.locator.com. I really dig this site because you can get a lot of radios across the country, radio stations across the country. You can find them, and I think it's really cool. But for example, there's a famous station in LA called KISS, K-I-I-S FM. We can just do the call letters, excuse me, and then it says Los Angeles, California. It gives us the website. It also gives us an audio feed address. This is really cool because actually a lot of these stations don't want you to have a direct link to their station. They want you to either play it through the web browser or some other way. They want to be able to throw ads at you. So what's nice is you can get this audio feed, and if you just click on it, it'll download that M3U file, and I'll show you what to do with that. So with the M3U file, we just need to open it up, and let's go ahead and edit it with Notepad++. And look at, once you open up that file, it actually is giving you a direct link to that station, and that's what you want to add to your MPC playlist. Okay, so we got this long string here for KISS FM. Let's just go ahead and do MPC add, and let's just type in manually the address. So we got. Okay, so I've added the KISS FM on there. Let's see what else we got. One thing you can do is you can do a local by zip. So I'm going to go ahead and look here in Baltimore. I'm looking for NPR, which I know is like 88 or 89. Let's see what it is. We have public radio for Baltimore is 88.1 WYPR. So this actually takes us right to the the home page. Let's see, is there any other way around it? Okay, yeah, so once I just click this info right here, this little thing right here, it gives me an M3U file that I can actually want to edit it. So let's do the same thing and edit it with Notepad++, and there it gives us an actual direct stream. So I'm going to add that. Okay, we've added that. Another one I like is the BBC. Okay, I'm looking for the world service. Let's see, this should be right. Internet radio, mobile links. Okay, so I got this page here. That actually looks like, okay, this is actually going to give us PLS files, but this will work just fine. Let's download the PLS. And we're going to do the same thing. We're going to edit with Notepad++. And a PLS file doesn't just have the one string like an M3U does of it. It actually gives you title and a couple of other different metadata there. But we want to, right here, if you see under File 1, this is the actual direct link. So we can just do that as well. We can do MPC add and then just type that in. Okay, so I've added that. So what you want to do is you just want to add as many stations as you want, whatever ones you like. Remember, if you get an .m3u or .pls file, just open it up in a text editor like Notepad++, or I think Notepad should work, regular Notepad, I'm not sure. But if you do that, then that's, and you want to look for that direct server link. That's the key, and you just want to build up your list, your playlist that's there. And just to show you, we can actually just do MPC play. And if you look, with the MPC next command, so that's Kiss FM, we actually can now cycle through these. Whoops, wrong. So it's giving me a problem with WYPR. Did I type that in wrong? I might have. This is kind of how you figure out if you did it wrong. Let's see what I did. HTTP str 3 a.m. Oh, I did. I missed a 10. So let me show you how to edit that and how we can actually delete that specific one. Okay, so I want to show you real quick how to delete this song that we accidentally added. This and the address is wrong, so it's not working for my public radio station. So to do that, we're going to do. First, we need to figure out the position number. So if you do MPC playlist, it'll actually list all the different songs in the playlist. And you can see right here, there is one that is. That's not showing up. It's not giving us a name or a title of it, and that's the one that we've had issues with. So actually, you could just count 1, 2, 3, 4, 5, and we know it's number 6. But if you have a longer playlist, this may be a bit problematic. So we want to do something like this. We want to say MPC playlist, and then we want to do the -F for format, and then we want to start a parentheses. We're going to tell it what string output we want. So the first thing we want is we want to do so we do the %, and we say position. This will give us the number in the playlist. This is really important. This is what we kind of want. And then you do a space, and then let's just go ahead and do a % again and do name. And then you just do a % to close it, and then you just do another quote to close the string. We do that, then it'll actually list with the number out in front our station. So we see that's number 6. So to remove that, we just do MPC delete, and we just say number 6. Oh, I think it's actually MPC DEL 6, sorry. Yeah, there we go. So now we can actually list again our playlist using that same command, and we see that it did delete the one that one station that wasn't there. So to add it, so I typed it wrong. Let me go ahead and do MPC add again, and I'm going to make sure I type it right this time. So I left off. I did 241 instead of 2410. We can WAPR. Okay, now if we look at it again. On 7 it should be there, so let's just see MPC play. And we can just cycle through our stations. Okay, there we go. So it's actually working, even though it may not have a title with it. Okay, now it has a title. It took a little while for it to load up once we actually ran it. MPC stop to stop the player. Okay, the reason I showed you all that because this is what the code is basically doing. It's just going to be sending those terminal commands to go next and previous and those sorts of things. But I wanted to show you how to build your playlist first, and that's a really basic tutorial. You can save the playlist, load the playlist. There's lots of things you can do with it. But for now, I just wanted to show you those basic things and how to kind of manipulate the output that you'll get, and that'll allow you to do some extra stuff later if you want to actually have metadata displayed specifically on the LCD display as you want it, or if you want to pick out the actual number of the current track and those sorts of things, which I didn't do for this tutorial, but I just wanted to show you that those options are there if you wanted to do it. Okay, so now we want to actually get the script that's going to be our internet radio script. So to do that, we want to get WinSCP again. And we want to go to our projects radio folder, or whatever folder you've put everything in. And you want to grab radio.py, and then you just want to drag and drop it over there. I already have it in there. So it should be in there. So if I actually go over here, so you see I'm in projects radio, and if we list it, ls, sorry. We see radio.py is in the folder now. So in order to run it, we just want to type sudo python radio.py. Okay. So it actually started off where we left off, but I want to show you now what's actually happening over here on the Raspberry Pi when we do this. So I'm just going to stop it first. Okay, I really quickly wanted to go through the radio script and just describe what's going on very briefly. This is radio.py, and you should have already, or you're about to, we're about to move this over to the Raspberry Pi using WinSCP to put it over into our current project folder that we're working on for the internet radio. But a couple things that are important. I do have some different notes here kind of describing how you would the different pins on the RGB display, LCD display, all 18 of them, and kind of what all each of them mean. Then you can see right here below we have the this is where we assign the GPIO numbers that were for the LCD display. And this is kind of a point that took me a little while to figure out. But 25 actually refers, if you see the LCD RS, we're actually talking about this register select, which is number 4. That's where we have that plugged in to GPIO number 25. And if you look a little bit further down right here in the main where we do set mode GPIO.BCM, the BCM is referring to the Broadcom names for the GPIO names that we're going to be using. So this is actually referring to GPIO number 25. And if you look on that little, if you look at Gert's tutorial, he has a link to a little printout of this that I printed out, and I was showing you that card. But GPIO 25 actually refers to, that's the Broadcom name, refers to pin 22 on the Raspberry Pi GPIO header. And so actually, if you look at the Raspberry Pi name or the physical name, that's GPIO number 6. So we could just put 6 here, but then we'd have to say this is it would not be BCM. I think it'd be I don't know. Raspberry Pi. I can't remember what this is. You guys could probably. I forget. I always use the Broadcom names because it's easier for me. Because my breakout board is that way. But anyways, just so you know that's actually called the GPIO 25, and that's the Broadcom name. and we go through all of them here for the LCD displays that and so we're using up 6 pins here, and here's the 2 other pins that we're going to be talking about for our radio controls. So we have 18 for the GPIO 18 for next, and number 4 for previous. And we do another number of initializing things here for the LCD display. We throw in the width here. It's 20, not 16, like a lot of the 16 by 2s. This is a 20 by 4. But you can see real quickly how you would change this. You could just actually delete these 2 lines right here, the 3 and 4. If you just want to do lines 1, if you had a 16 by 2 and you would just put LCD width equals 16, and you would just delete these and just leave 2 of them, 2 lines, some timing things. And then as we get into the main program block here, we initialize all of our GPIOs as either outputs or inputs. So we have all of the LCD ones are outputs. And so this just refers to that variable that's giving us the integer that points to the actual GPIO number, and we designate as GPIO out using this GPIO.setup. And then our 2 inputs are next and previous, and those are GPIO ins. We initialize the display, and then we kind of set up some basic text right here, just to, when it first turns on, when the program first runs. Now we have an endless loop here, a while 1 being true. So while we're just going to do this as long as 1 is true, which is always true. So this is kind of like an Arduino, where if you want something to just repeat over and over again, you do a loop like this. And we have 2. We want to detect if we have a button press for the next station or the previous station. And that's what we use here. So we say GPIO.input next equals true equals true. So if that's the case, then we actually want to go to the next station. And I forgot to mention what we're importing. So for all the GPIO stuff, we're using you're going to need what is it? This Raspberry RPI.GPIO. And you can download that and go to Gert's tutorial to figure out where to download that and how to install it. But we're importing that, and we also import, these are built into Python, time and OS for operating system. And we use the OS command by doing something like this. So when the program first loads up, we say os.system, and then we put we get on this function, and we put in quotes the actual terminal command, just like we were doing before. We say MPC play space play, and that'll just start playing MPC, playing the current station there. And just likewise, as you have, if you press the next button, and if it's true when it's pressed down, then it'll tell the system to run a command called MPC space next. So you can see we're just running basic terminal commands like we were before. And we're kind of waiting for a second in between there, just to make sure we don't hit it multiple times accidentally. And then if we want to actually grab some information off the screen, so we want to run the command MPC current, but we use this specific function. It's so we say we assign it to a variable. It's going to give us something. We're calling it f, and we use os.popen, and then we say MPC current. And so we want to actually get the name of the current station that's playing. So we initialize a string here called station, and then we have to loop through using f.readLines, and we do a for loop there. And then to station, we're just building that string up for each of those lines that's there. And then we just display the current station out here on these different lines, and we're actually just doing it on line 1, and then we just clear out lines 2, 3, and 4. That's how you do that. Then here's just some more back-end stuff that I'm not going to go into, but that's the basic idea behind what the program's doing. It's very simple. Obviously, we're not controlling volume, but you could, because you can just say MPC space vol, VOL, space, and you give it the volume number that you want. So it can be so anywhere from 0 to 100. Also, MPC space toggle will give us, it'll just toggle pause or play. So that's your pause button. So some of the things we run into are a limitation on the number of GPIO input outputs that we have. And so right now we're using 8 of them, which is the maximum that we can use right now if we're just doing it straight off of the GPIO header. So there are ways around that. And I think that's another tutorial for another time. Another thing we could do is, instead of using all these pins up, we could maybe use an I2C or an SPI backpack for the LCD display and only take up 3 pins or so. That's another thing. Anyways, so that's the basic program, but now you're going to want to just go ahead and, if you haven't done so already, is just to download this particular script and then move it over to Raspberry Pi using WinSCP like we've done before.
Alright, so it's now time to fire this thing up and see how it actually works. We've just transferred over the Python script that controls our little radio player. So I'm going to go ahead and start it up.
But that is the scream of dry ice.
And this is just a tiny lump the size of a
so
nail.
we see everything's working on our LCD display.
I'm pressing a small piece of
There's
dry
our setup.
ice against.
Now let's see how
film
our
of
next and
so
previous
what
buttons
else?
work. So if we hit next, previous,
gas without
previous.
and they will learn two things.
Alright, so as you can tell, it's working. It's doing basic functions, moving it forward and backwards in the playlist. And we could just easily add a Wi-Fi dongle and make this thing portable. Right now I just have the audio out going to my computer speakers, but we could just easily add, I have a little dock over there that we could just add it to, or your own speakers, so to anything. So that's it. This is kind of, let me turn it off. So basically, that's it, and we've created this is an awesome little tutorial just to show you how to get started on doing a internet radio player based off the Raspberry Pi. Using the LCD display to display the station name. What would be nice is to be able to add some better metadata there, instead of just showing kind of the raw output of the station title that we have from MPC that it gives us. It'd be nice to be able to parse out some of that and use up some of these cool lines. We have 4 lines on the display, so it'd be cool to put, like, I think in one corner to put the station number out of how many stations we have. So a lot of that can be done. I just haven't coded it up yet. I just wanted to show you guys how to get going, kind of the basic concepts of using the GPIO, how to hook up an LCD display and get that working. So yeah, that's it. I hope you guys like it. If you have any comments or questions, let me know. And if you like this tutorial, be sure to like it, and feel free to subscribe for more tutorials. Thanks.